Now let us discuss about the topic of vertical angle, calculation of vertical angle using theodolite. So the calculation of vertical angle is the advantage of our theodolite. Okay, now with the help of compass or dumpy level, we cannot calculate the vertical angle between the objects. Okay, now for example, if I need the height of the building, okay, now so I can go with some indirect measurements. Okay, now that time I am in need of the vertical angle between the foot to top of the building. Okay, now so that time we didn't go with either compass or dumpy level. So with the help of theodolite only we can able to calculate our vertical angle between the foot to top of the building. Okay, that's why this is the advantage of our theodolite whenever we are doing with the experiment using theodolite. Okay, now what is vertical angle? It is an angle between the inclined line of sight and the horizontal line of sight. Okay, it may be an angle of elevation or angle of depression according to the object as it is above or below the horizontal plane. Okay, now these are all the cases in general we can have to calculate the vertical angle. Here in the figure A, one angle is above the horizontal line. Okay, now then another angle is below the horizontal line, so that the angle of elevation and the angle of depression we can get it. In figure B, there are two objects A and B. Okay, now so with respect to horizontal line, these objects have an angle of alpha and beta. So these angles are above the horizontal line. So these are called as angle of elevation. And in figure C, with respect to the horizontal line, the objects A and B and their angles are below the horizontal line. Okay, so these angles we can call it as angle of depression. So how the way we are going to calculate the angles, that we are going to discuss right now. So whenever we are going to deal with vertical angle, okay, now so the vertical circle and the vernier C and D, we are going to see the readings. Okay, and when we are doing for temporary adjustments with respect to altitude bubble, we have to do our leveling process. Okay, now so that altitude bubble is attached nearby our telescope. Okay, so if we are going to calculate the vertical angle, then we have to deal with altitude bubble. Okay, now so while doing the process, say centering process and the leveling process, so okay, that time we have to see the bubble, altitude bubble, that should be at center. Okay, now while doing the leveling process. So now the procedure to calculate the vertical angle. Okay, now first I am assuming that here I am having some buildings. Okay, so this is my ground level and this is my building. Okay, so this is my top of the building. So this is my building. Okay, here I have to calculate the vertical angle with respect to the building, top and the bottom point of the building. Okay, first I have to place my instrument at station point O, and I have to do all the temporary adjustments such as setting up, leveling up and elimination of parallax. Meanwhile, my instrument optical center should be oriented with my station point O. So likewise my setting up process should be, centering process should be, okay now. After doing all the initial adjustments, okay now, with respect to face left observation, okay, I have to rotate or transit my telescope and have to focus the top of the building. Okay now, here the line of sight or horizontal line indicates the 0 degree angle with respect to the verniers C and D. Okay, 0 degree, 0 minutes and 00 seconds with respect to horizontal line. If I am going to focus and bisect the point A, and with the help of vertical axis screw, okay now, in the figure we will see. So here I am having vertical clamping screw, okay. By loosen and tightening this, I can arrest the movement and movement of the telescope, okay now. But when I am going to loosen it, the telescope can be rotated in the vertical plane easily, okay now. If I am going to tighten it, then the telescope won't move in the horizontal plane, okay. Now, okay, by loosening the vertical clamp screw and by focusing and bisecting the point A, that is top of the building, okay now, I can, that is in the vertical circle, the readings, vernier scale C and D readings has been changed, okay now, from 0 degree to some angle. For example, this angle alpha is the angle of elevation, since we are focusing the top of the object. Example, I am getting it is 20 degree, okay, 20 degree, 0 minutes and 00 seconds, okay. This angle alpha is called angle of elevation. Then I have to transit my telescope from, by focusing the top of the building to bottom of the building, okay now, so that once again we can reach the horizontal line. At that time the reading is 0 degree, then once again it's going to get down it, okay now, so that we have to focus and bisect the point B and have to read the vernier C and D scales. For example, in vernier C, if I am going to get some 30 degree, okay, then my angle AOB becomes the addition of alpha A plus alpha B, the addition of alpha and beta, so that the angle becomes 20 degree plus 30 degree is equal to 50 degree is my vertical angle, okay. So whatever the angle I have found here, that I have to represent in the form of tabular, like this, instrument at O, side to A, so that my reading is here vernier C and D I have to take, okay. So here it is vernier C and D. So the angle of elevation here, okay now, which is 20 degree, 0 minutes and 0 seconds, and in the vernier D reading becomes 0 degree and 0 seconds, so that the mean angle is 20. That is by taking an average between vernier C and D. Okay. Next, the vertical angle becomes 20 degree. Next, with respect to B, that is instrument at O and side to B, we are getting the angle of 30 degree, so that in vernier C is 30 degree, vernier D is 0 minutes and 0 seconds. Okay, so that the mean angle between vernier C and D becomes 30 degree. So the vertical angle is 30 degree. Okay. Now the angle between AOB is equal to addition of these two angles. So it becomes 50 degree. Okay. Next, this is with respect to face left observation, which means our vertical circle is at left side of the observer. Now we have to do the face right observation for the same. Okay, now so whatever the procedure we have discussed earlier, same we have to follow and have to get the readings. So whatever the readings we can get according to here, the same value we have to get it from face right observation also. Okay, now so that our vertical angle becomes, here it is 20, 0, 0, here it is 30. So the mean vertical angle is summation of, or by taking average, okay, now between face left and face right observation, which becomes 50 degree. Zero minutes and 0 seconds. This is the way we have to calculate the vertical angle using theodolite.